In this video, I demonstrate how to set up a VPN tunnel between a routing and remote access server and Azure. Hello everyone, my name is Travis and this is Seraltos. I set up a VPN connection between a VNet gateway in Azure and a routing and remote access or RRAS server last year to connect my home lab with my Azure network. At the time, my home lab was just a VMware workstation running a couple VMs on a desktop. My lab has grown and most of my VMs are now running on a Hyper-V server with the exception of that routing and remote access server. In this video, I go over deploying a new RRAS server and connecting it to an Azure gateway. The process is not limited to home labs. It could be used for a small office or an environment where a site-to-site VPN to Azure is required. Also, if you plan to take an Azure certification, such as the AZ-103, walking through this example with me will give you some good hands-on experience without having to purchase a VPN appliance. Before I get started, please take a second to subscribe and click the bell icon to get alerts on new content. Also, click the like button. That helps support this channel. Let's get started. There are a lot of different configurations that this will work with. For example, I currently have a single subnet on my home network. The RRAS server sits behind a cable modem and VPN traffic is forwarded to that RRAS server. In this configuration, I have to set a static gateway to the internal RRAS server for any servers that need to connect to Azure. But I have a couple teenagers in the house, and with all their devices and smart TVs and home automation, my subnet is getting stretched. There's not many IPs left for servers. My new configuration will look something like this. The plan is to have one subnet on the Hyper-V server for my home lab. The RRAS server will act as a gateway for that subnet. This will free up IPs on my home network and isolate my lab traffic on its own subnet. I put this project and this video off for a while because I wasn't sure how to address the local networking aspect. There are so many different configuration options, I couldn't possibly address all of them in this video. So I'm just going to say that any device that needs to connect to Azure over the VPN will need the RRAS server set as its default gateway. I suspect most people watching this video will know how to set DHCP or a static IP entry and make that happen. But for this video, I'm going to focus more on creating that VPN tunnel between the two endpoints and not so much on the actual networking behind it. There are a couple things needed to get this set up. First, a Windows server to host the routing and remote access role. I'm using server 2019 in this example, but 2016 would work also. This server will have ports open to the internet, so it will not be domain joined. My current setup is running server core, but I had some issues with configuration settings, so I'm using the full desktop in this example. The server has an internal and external NIC attached connected to the internal and external subnet. I also have an Azure subscription and a VNet set up in that subscription. I have admin rights to the firewall with the option of port forwarding on that firewall. You do not need a static public IP, but one that's relatively consistent will help a lot. I'll dive into that later. The last item is cost. Using a basic gateway, this setup cost me about $25 per month. Your cost will vary depending on traffic and the size of the gateway selected. It's not possible to deallocate gateways like you can with a VM, so as long as it's on your subscription, you're getting charged for it. That's a good reason to set up budgets and cost alerts on your subscription. I have just the video for that. I'll share it above. Here's an overview of how this will look once finished. If I had an enterprise firewall, I could just handle the VPN termination there, but I don't, so instead I'm forwarding IPsec ports UDP 500 and UDP 4500 to the RRAS server. As stated, this setup requires that you forward inbound traffic. You'll need to verify that your modem, ISP, or any other device is not blocking that inbound traffic. It's possible that some of you may have a modem that's also a firewall. You'll have to figure out how to forward ports in that situation. As I said before, there are a lot of options and I can't cover every scenario. To get this to work in whatever setup, those two ports will need to be forwarded to the routing and remote access server. Here's the steps we're going to go over in the demo. We're going to add the routing and remote access role to the server. We're going to create an Azure network gateway. We're going to create a local network gateway in Azure. We're going to configure the routing and remote access for the VPN, and we're going to create the connection and then test. Let's get started. Here I am logged into the routing and remote access server. I'm going to go to Manage, Add Roles, and Features. I'll click Next to step through the wizard, selecting the local server. Under Server Roles, select Remote Access and click Next. Click Next at Features. This will take you to Remote Access. Under Role Services, select Direct Access and VPN. At the screen that opens, select Add Features. Next, select Routing under Role Service and click Next. Continue by clicking Next on the confirmation pages and then Install. It'll take a few minutes to finish. Once done, open Routing and Remote Access to verify it installed. The service will show stopped. We'll come back and finish configuration shortly. Okay, to get started, the first thing I'm going to do is create a gateway subnet. This is a subnet in the VNet with the name Gateway Subnet. It has to have that Gateway Subnet name. You do have the option to set this up when you deploy the gateway, but I want to set it up in advance so we can see the whole process. So the first thing I'm going to do is go into my VNet and go to Subnets. And I'm going to create a gateway subnet. I'm going to change this to 10.0.200.0. And really, you can use any subnet you want for this. I'm just picking 200 kind of at random. And I'm going to put a /27. Minimum is a /28. But I'll just add /27 so there's a couple extra IP addresses in there. And the rest can be left as is. I'll click OK. And now it's creating that subnet. There it is. So we can go in and see that gateway subnet. It has the IP addresses of 10.0.200.02.31, and the rest can be left as it is. Now I'm going to go back to my network resource group. Next, I'm going to create the virtual network gateway. I do that by creating a resource, and I'll search for a virtual network gateway. And here it is. I'll select Virtual Network Gateway and Create. I'll leave the subscription as pay-as-you-go. I need a name for this, and I'll call it Lab GW for Gateway 1. You may notice that the resource group will be the resource group of the virtual network that you select later on. So I'm going to select the same location as my virtual network. The gateway type is VPN. And the VPN type is route-based. Route-based gateways direct traffic based on the routing information in the routing table and forward packets to the proper tunnel interface. The packets are encrypted and decrypted in and out of that tunnel. Policy-based, on the other hand, encrypts and directs packets based on the IPsec policy configuration with a combination of address prefixes between your on-premises network and the Azure VNet. This is available only for basic gateways and is limited to one tunnel. So I'm just going to leave this as route-based. The SKU is going to be a basic, and the only option is generation 1. The basic SKU is considered a legacy SKU and has some feature limitations, but it is the cheapest and it works well for a lab. I'm just going to select my virtual network, and you can see next it's going to pull that gateway subnet address that we already configured. I'm going to create a new public IP address, and I'm going to give this the public IP name of, let's see here, labgw_PIP. And I'll leave enable active mode and configure BGP as disabled. Next is the tags. I'm just going to give this, let's see here, department, and I'll give it IT. Review and create. The validation passed, so I'm going to hit create next, and I'll wait for it to finish. This will take sometimes up to 45 minutes to finish. So I'm just going to let it go. I'll pause here and I'll be back once it's finished. I'm back and the virtual network gateway has finished. It did take quite some time, but let's move on. So the next thing I'm going to do is create a local gateway. So what this is it's a representation of your VPN endpoint in Azure. This is where it gets some of its configuration information and how it knows what to connect to. So let's create a resource and search for a local gateway or local network gateway. There it is, and I'll hit create. So I'll give it a name, and I'll just call it Home Lab. Now the IP address is the IP address of the endpoint. So this would be my local, and again, local refers to local to me, not to Azure. So it's my home network external IP address. And I like to use a tool called IP Chicken to find this. You can use any tool you want to, but ipchicken.com will give you your public IP address. So I'll come back, copy that, and paste it in. Okay, so next is address space. So what it's asking for is what are the address spaces or the subnets on that remote network. And in my case, I'm only going to have one, but you could have multiple. Okay, so my remote network is going to be 192.168.200.0/24. And again, I could add more if I wanted to, but I'm not. I'm not going to configure BGP. I'll leave the subscription as is. And the resource group, I like to put all my networking objects, at least for a specific region, in one resource group. They're easier to find that way. I'll leave the location to Central US. And next I'm going to click Create. Next thing I'm going to do is hop back to my local remote routing and access server and finish the configuration on that. So here you can see I have two network cards. I've got an internal that's connected to an internal Hyper-V switch. So I can route traffic from anything within that Hyper-V host and the host itself over that interface. And that doesn't need to be a static IP address because that's the gateway for anything on that 200 network. So external in this case is just external to the internal network, I guess. So that's going to be connected to the 192.168.254 network. Again, that's just the same network as all of my household appliances are on. And then that's going to proxy the connection out over the internet connection. But anyway, in this little environment, external is just external to that internal network. And that's what's going to connect to the internet. So now I'm going to go into Routing and Remote Access Services. And I'm going to right-click and configure and enable Routing and Remote Access. So I'll click Next at the wizard. For the configuration, I'm going to use Secure Connection between two private networks. I'll click Next. And I'll leave Dial Demand as Yes. And my clients are going to get an IP address automatically. So I'll click Yes. And I can leave that as is and just click Finish. And we'll let it get the services started, and it's going to prompt me for another wizard here in a second. Okay, here is the demand dial interface wizard, so I'm going to click Next, and I'll give this interface a name, and this is the interface that's going to actually connect to the VPN endpoint in Azure. So I'm going to call it Azure GW, and I'll click Next, and I'm going to connect using a VPN. And for the VPN type, I will select IKE v2. Now it's asking me for the remote IP address of the host. I'll find that located in the public IP information on that gateway. Let's hop back to the Azure portal and we'll get that information. We'll go to resource groups and everything is in my network RG resource group. And lab GW1 PIP for public IP. And then I'm just going to copy that. That is the IP address that it's going to connect to. I'm going to leave this as route IP packets. Here it wants me to configure a static route. So what this does is it tells the routing and remote access server anytime it gets an IP bound for a specific IP address to send it out the VPN interface. So in order to do this, I have to add a destination network. And what I'm going to do, let's just hop back to Azure because we really didn't talk about this. If I go to Network RG, I'm going to go into my virtual network. Under address spaces, there's the address space that VNet will host. In this case, it's 10.0.0.0/16. So anything within that address space could exist in this VNet. And that's further cut down into subnets. So that's what we actually assign NICs to. But here it's saying that anything in the 10.0.0.0/16 could exist on this VNet. So I'm going to go back and add 10.0.0.16. And for a /16, the network mask is 255.255.0.0. And for the metric, I will just put 10. So there it is. And then I'll click Next. And for this dial out credentials, I can leave that blank for now. And finish. Okay, let's review that to make sure it's set up. Okay, there it goes. So network interfaces, here's the Azure GW. Dial demand, it's enabled, but it's disconnected, which is what I would expect. And let's go into IPv4, general, dial demand. There's nothing showing there. Static routes. Now, I actually had a problem with this, and I thought I was going maybe a little bit nuts, but so under static routes here for IPv4 and IPv6, there's nothing. And the problem is we just set that up, but it's not here, so I'm not sure if that was for something different or what's going on, but you do have to add a new static route. This is a repeat of what we did before, but all I'm doing is adding that same destination. And the metric, I'll change that back to 10. So although I thought I set this up when I deployed the network interface, it didn't take. So this, you can see here, it's going to use this route to initiate the demand dial connection. And I'll click OK. There, now our static route is in there. That is important. This won't work without having the static route in. And again, that IP address is the address space on the VNet in Azure. Okay, so that's set up, but we still have to go back to Azure. Here we go. I'm going to go back into my network resource group. I'm going to go into the Home Lab local network gateway. And under connections, I'm going to add a connection. So a connection is the representation of the actual VPN tunnel. This is where it's going to get some VPN information and the shared key. So I'm going to call this lab connection. I'm going to select lab gateway 1 for the virtual network gateway. So that's the gateway in Azure. Home lab is already selected for the local network gateway. So again, that's the endpoint, the VPN endpoint on my local network. And under pre-shared key, I'm going to call this new key 123. And of course, that will be changed by the time you see this. I'll leave it IKEv2, and the rest is the same. I'm going to click OK. I'll give it a second to create it. There it is. It's updating. If we come back, when we come back in a couple minutes, it'll say it's trying to connect. I'm going to hop back to the server and see what's going on there. Let's see, network interfaces. It's disconnected. Now there's one more thing I need to do before this will connect. I'm going to go back to my web browser, and I'm not sure how much I'll actually show you of this, but this is a dated firewall that I use on my network. But what I want to show is that under virtual servers and port forwarding, I have 2 ports forwarded. They're UDP 500 and UDP 4500. And right now they're going to 192, 168, 254, 200. That's my old server that I had set up. Let's go back to my server. I'm just going to run command here. Here, the external interface, which is going to connect to that subnet, is 201. So I need to go back, and I need to update this. So I'm going to change it from 200 to 201. Okay, that's saved, but this router will not take that configuration until it's rebooted. So I'm going to reboot it real quick and then come back and finish out. While we're waiting for that to reboot, each router is going to have a different configuration. As I said before, maybe you have a cable modem or DSL modem and firewall combined. I happen to have them on 2 separate devices. So it could be, there could be a lot of options in how to configure port forwarding. If you're having problems, I'd suggest standing up a IIS or a Apache server on that network and hosting a simple website on port 80 and configure your router to route external traffic to that. Once you're able to forward traffic to a web server, you should be able to use that same configuration as guidance to forward traffic to the 4500 and 500 UDP ports. It's just a little bit easier to troubleshoot if you can see that ports are actually being forwarded correctly. Okay, so that's done. I'm going to go back to the server, and I have one more thing to do. I'm going to go into this gateway. I'm going to go into properties, security, and I have to add that passphrase. So there it is, and I'll click OK. Now let's go back to the portal. That is saying updating. Let me just refresh it. Okay, so that's set to connecting, but it's not connected yet. And the Azure GW interface still shows disconnected. This is a demand dial interface, meaning it actually has to get some traffic before it'll connect. So let me just ping something on the Azure subnet and see if I can get that connection to get established. Okay, that failed, but let me go back, do a refresh. Oh, there it says it's connected. I'm going to refresh this. Still says connecting. Okay, there we go. Now it's connected. And just to let you know, I did have to restart my router a second time. Not quite sure why that is, but that was a issue on my end, not with the RAS server or with Azure. Let's come back, and we can see we've got some traffic getting past. Let me try pinging again. Creating a ping from this computer initiated a demand dialing session and connected. The problem is the traffic is still coming from a 192.168.254 IP address, not the 200, which was defined in the local gateway. So what I did is I just added a server here. So this is the IP address of 192.168.220. Here you can see, and what I'm going to do is simply try to ping that server in Azure. There we go. Now we're getting a reply back. And I can show that here. If we go to the home lab and we go into, let's see here, configuration, you can see I have an address space of 192.168.200. So that's telling the gateway and the VPN connection that that subnet exists on the other side of that VPN connection. But what I don't have in here is 192.168.254, which is the IP address of that routing and remote access server. So it's not going to return traffic to there, but it will return traffic where it matters, and that's anything on that internal .200 subnet. Now if I minimize this and come back to the routing and remote access server, we can see that we have the demand dial is passing traffic in both directions. Okay, so we can connect to a server that is located in the Azure subnet, but one problem we have is I can't really connect to anything else. So for example, if I try to simply ping a DNS server, it won't work. And that's because we haven't configured the routing remote access server to act as like a proxy server. So let's go back here and we're going to go into NAT. So this is going to configure the network address translation. So everything in that internal subnet is going to be masked or natted behind the external interface. So we do that by adding a new interface. I'm going to pick internal. I notice I have two of them here. Could be because of some of my testing, or maybe you'll have two as well. I'm just going to pick the first one and see if that works. And that's going to be the private interface. So internal is the private. It's the only option here anyway. And then I'll click OK. And next I'm going to add another new interface. This time is external. I'll click OK. And I'm going to change this to public interface. That's connected to the internet. And I'm going to enable network address translation on this interface. So I'll click apply and OK. And now let's go back and see if I can ping that server. Yep, that works. Let's just see. Let's see what IP chicken says. There it is. So that is now working. These servers can get to the internet, and they can also get to the subnet in Azure. Okay, one more thing before we go. What happens when your ISP changes your public IP address? So you would notice that this would break. This wouldn't work. So what would you do? You would go back into Azure. You would find what your new external IP address is using IP chicken or something like that. And then come in and find your home lab configuration and update the IP address in configuration to the new IP address. And that should take care of it. That is a downside to having a home lab behind a dynamically assigned public IP address. But to be honest, I've done this and I don't think I've had to change it once, just because my internet connection is always on. And even if it restarts, it normally gets the same IP address back. But I'm sure all ISPs are different, so some people may be changing that more frequently. Okay, so I think that covers it for the demo. We added the routing and remote access service roles. We got our public IP address for the local network. We created a gateway in Azure and the gateway subnet. We created a local network gateway, and then we created a connection. We finished configuring the routing and remote access server. That included changing the port forwarding on my firewall. We created a connection, and then we finished it all up. Then we tested it by running a ping command from a server on that internal network. That's it for the demo. That does it for this video. If you found it helpful, please subscribe and click the bell icon. Thanks for watching.